minus 1. Okay, like I said, I'm sure by now you have enough practice. Okay, so now this is what you have left. So what do you get here? You get negative 5 upon 4. Okay, so I'm sure you understood this part and how I went from here. So now let me show you this one. Now these are two fractions, okay? So you have 1 upon 4 minus 1, okay? So now obviously guys, what is the LCM here? The LCM is obviously 4, okay? So 4 divided by 4 gives you 1. So when 4 divided by 4 gives you 1, then you multiply by negative 1. So when you multiply by negative 1, you get negative 1. So now you have obviously a minus sign. So a minus sign has to be a minus sign. So here obviously you assume this 1 here to be 1 because there's no number in the denominator. Okay? So 4 divided by 1 is 4. And then 4 multiplied by 1 is 4. Like you get here. So then you get negative 5 upon 4. Okay, you get negative 5 upon 4. Okay? So guys, now what do you do? What do you do now, guys? Okay, now that you've got negative 5 upon 4, that's how you get negative 5 upon 4. So now that you've got negative 5 upon 4, what do you do now? So guys, there are two ways you could do this. You know, it's kind of tricky, but you can either cross multiply, but after cross multiplication, you'll have to divide again. So, or you could take 4 as the LCM, and you could say negative 2x equals. So it doesn't matter. You're gonna have to, divide either way. So I'd rather cross multiply. Okay, so you get negative 4x equals negative 10. Okay? Okay, this is what you do. You cross multiply. Okay? That's what you do. Okay, so now guys, negative and negative becomes positive. So x becomes 10 upon 4. So when x is equal to 10 upon 4, I hope you can see that. So x becomes 5 upon 2. Okay? So guys, here what happens, guys? So here, okay, so what is 5 upon 2, guys? 5 upon 2 is 2.5, okay? So negative 2.5 divided by 2 is negative 1.25. So negative 1.25 plus 1 is obviously going to be negative 0.25, which is a 4. So you're practically correct. Now remember guys, sometimes when you have linear equations in fraction or in decimal form, you may have gotten the right answer, but you might have got it in a different form, and you may not know the form that you have as a fraction or a decimal is equivalent, and you might think it's wrong. So make sure you're good, at integers and in all sorts of fractions. Like make sure your arithmetic is good, otherwise you're going to be trapped. Okay, you're going to be trapped, absolutely. Okay? So now guys, we're going to do one more question of this type. We're going to do one more question of this type, okay? And it's going to be absolutely tricky. Okay, it's going to be absolutely tricky. And then I think we'll leave it there. Okay? We'll leave it there because a lot of, there are a lot of reasons why I want to leave it there. I think this is, and I think that this is enough for you guys for one day as well. And then guys, obviously there's a lot of noise coming from a lot of places, so that can also ruin everything for you. Okay, so let's just do one more and then we'll leave it there. Okay. Okay, so let's do it. Yeah, the board is horrible. It's atrocious. Okay. So negative 3 upon 5. Okay. Plus x upon 10. Okay. Equals 1 minus 5 minus x upon 5. Okay. So how would you solve this? How would you solve this, guys? How would you solve this? Okay, guys, this is a very tricky one. So now, guys, there are two ways you can solve this. There are two ways. You know, you can either use the ax plus b equals cx plus d. You can either use that form and solve it. But I think you know, guys. Well, obviously, guys, that's one way you can solve it, and I think that's the best way you can solve it. But solving it that way is gonna be a little tricky for you guys. You know, guys, another way to solve it is you can solve these equations individually. Like, guys, it doesn't matter. It doesn't matter which way you decide to solve it. You know, you're gonna have to solve it in that form eventually. What matters, guys, is that do you want to transpose and solve in that form, or you want to separately solve these? I mean, my advice to anyone would be is that, you know, just combine like terms and solve it. That's more logical. That's much more easier. This way, you're just gonna get confused and lost. But just give it a try, and then we'll solve it together, and then we will leave it there. Okay, we will eventually leave it there. Okay, after solving this. Okay, but just give it a try by yourself. Just give it a try by yourself. Okay? And then, guys, remember that I've discussed many linear equations with you already. But guys, this is not the end of it. You know, in future videos, I'm going to discuss even harder linear equations with you. Linear equations in one variable, even harder ones. And then I'll come up with more similar videos of different types of equations and all sorts of things. So the best is yet to come, guys. Don't worry. You know, if you're someone who's struggling in math in school, don't worry. I'm here to help. Okay, so let's do one thing. You have x upon 10, okay? So now on the other side you have negative x upon 5. So when we transpose that, it becomes plus x upon 5. Okay, so this is x upon 10 plus x upon 5. Okay, so now you have negative 1 upon 5. Okay, so now let me just go a little slow. I think I'm going a little too fast. So you have minus 3 upon 5 equals negative upon 5. Okay, so now we transpose this. So when we transpose this, what do we get? We get negative 1 upon 5 plus 3 upon 5. Okay? So now what do we do? Like I said, guys, this problem is a little bit tricky. Okay? Anyways, don't worry. So now, guys, here, what do you get? You obviously get 2 upon 5. Okay? You get 2 upon 5. Why? Because you have the same denominator. So when you have the same denominator, the number stays the same. And so negative 1 plus 3 gives you positive 2 because you have more positives than negatives. So that's why you have 2 upon 5. Okay? So here, the answer to this is 2 upon 5. So this is what the answer is. Okay? Because look, when 5, guys, when 5 here is the denominator, like when 5 here is the LCM, so 5 divided by 5 is 1. So 1 multiplied by negative 1 is negative 1. Then you obviously have a plus operation. And then you have 5 divided by 5, which is 1. So then 3 multiplied by 1 is 3. So then you have negative 1 plus 3 upon 5. So obviously you have to carry the LCM, which is 5. And then you get 2 upon 5. Okay? So let's erase this. Okay, let's write 2 upon 5 here. Now there's not much space, so we have to kind of improvise. So this is 2 upon 5, guys. Let me just write the 2 better. That 2 is looking like a sitting duck. Now I have very less space. So if I don't improvise, this equation itself is going to become like a sitting duck. You're not going to understand what's going on. And I'll look like a sitting duck as well. Anyways, let's do it. So now guys, this is now going to be a very awkward situation now. Where do you go from here? Where do you go from here? Where do you go from here? Now guys, a linear equation like this can perfectly come on a test or on an exam, because the examiner knows you're going to be stumped by seeing this. Even if it's in a fractional form, you're just going to be stumped. You're going to be like, oh my god, what just happened? Okay, don't worry guys. So guys, there are 2 ways. You can either use the LCM, okay, and you can solve it. So, let me just show you both the ways, because I think it's important. So let me show you the first way. The first way, guys, is you take the LCM. So the LCM here, guys, is 10. Okay, guys, not 50. Okay, you could take 50 as the LCM, but then you're going to get even bigger numbers. You're going to have to add, subtract even bigger numbers. It's going to make your life way more complicated, way more difficult. And, I don't think we need to go to the ends of the earth to solve